I'm going to be trying something a little bit different. I'm going to be making several different videos, and then I'm going to be posting them to our Google Doc. One's going to be the warm-up, and then another is going to be some other activities. So the first thing that I would like you to do is, if you could please go ahead and turn to page 55. We're going to go ahead and take a look at our warm-up here. And for our warm-up, we have consider the tips of the hands of an analog clock that has an hour hand that is 3 centimeters long. So that's going to be our hour hand here. And a minutes hand that is 4 centimeters long here. Okay. So what I want you to do is I want you to, knowing this information about the two clocks, I want you to go ahead and pause the video and answer these 3 particular questions that you see here. Go ahead and pause now. So hopefully you've gone through and answered the question. So the direction states, we got 2 hand clocks here, and what is the furthest that the 2 tips are going to be apart? So hopefully you are thinking, okay, well, this depends on what time of day it is, but the biggest thing is the furthest that the 2 tips are going to be apart is whenever they are completely opposite of each other. Okay, so the furthest that these 2 tips are ever going to be apart is going to be 7 centimeters. Now there is no specific time, as long as you can see they are opposite ends of each other, so it doesn't really matter as long as they go through and the one tip is on one side, the other is on the other side. So what is the closest that the 2 tips are going to get? At any point in time that the 2 tips are both facing the same direction is the closest that they could possibly get. Okay, so I'm giving several different examples here. Obviously the ones that I'm giving are going straight to a specific number. However, I could also use something like this, or no, let's not do that one. Let's do this one here. These are just several examples of distance as what it's going to be. But if the longest one is going to be 4 centimeters and then the shortest one is going to be 3 centimeters, then the closest that these 2 are ever going to get is they are going to be 1 centimeter apart. That is the closest that the 2 tips will ever get. So the question then states, are these 2 ever 5 centimeters apart? Okay, now the interesting thing is currently right now, I want you guys to take a look. Some of you may think, I don't know if they're ever going to be 5 centimeters apart. Well, if you take a look here, currently how things are, we have our 3 centimeters and our 4 centimeters, and then 5 centimeters apart would be this line here. Okay, so like the orange line that I just drew in. Okay, so the question states, are they ever going to be 5 centimeters apart? Well, the only way that we can ever check that is if we create where the 2 form a right angle, at which point then it looks like it makes a triangle. Now the only way we can check this is if it is a right triangle, because we know that with our Pythagorean theorem that we can then check to see if it's true. So we have 3 centimeters plus 4 centimeters squared equals, and then the question says, is there ever a time where they're 5 centimeters apart? Well, we'll check the third random side is to be 5 centimeters. So then we have 9 plus 16 equals 25. Does 9 plus 16 equal 25? Yes, it does. So is there ever a time where the 2 tips are 5 centimeters apart? Yes. Any time that the hour hand and the minute hand form a 90-degree angle is when the 2 are going to be exactly 5 centimeters apart. Okay, so here's another question that I kind of want you to briefly just think about, and there's no correct answer for this. Well, there is a correct answer, but I just kind of want you to ponder it. So a question I have for you is, imagine that you have 2 hands that start in the exact location. So they both go up. Okay. And one hand is going to stay put, like typical clocks tend to do every once in a while, but the other hand is going to rotate, and then the distance between its tips is what's going to happen to the distance between the tips as the red one rotates around the clock. What's going to happen, the distance between the orange tip and the red tip as the distance rotates around the clock. Go ahead and pause the video here and think what your answer is. And hopefully what you guys are thinking is as the red one rotates around, eventually the distance is going to increase, and then hits the point of no return where they're complete opposite ends from each other, and then it's going to continue. After it hits the point of no return, then it's going to decrease again until it hits the point where it's the slowest. Okay, so that was our warm-up today. So go ahead and finish up what you can in your notes, and your next video will be online.